Welcome to our Arduino tutorial series. Today we are going to learn how to measure the distance to an object using an ultrasonic sensor. This handy device sends out sound waves and measures how long they take to bounce back from an object, and then uses this information to calculate the distance between the object and the sensor. For this project, you'll need an Arduino Uno board, an HC-SR04 ultrasonic distance sensor, an LED with its current limiting resistor, jumper wires, and a breadboard. Let's start by wiring the sensor to the Arduino Uno. I'll use the power rails on the breadboard for 5V and GND, ground. Connect the VCC pin of the sensor to the 5V output on the Arduino via the red power rail on the breadboard. This supplies power to the sensor. Next, connect the GND pin to one of the Arduino's ground pins to complete the circuit. Here I'm using the blue power rail on the breadboard. Now attach the trigger pin of the sensor to digital pin 8 on the Arduino. This pin will send the pulse to trigger the sensor. Connect the echo pin to digital pin 9. This pin will receive the echo and help determine the distance. And finally, connect the anode of the LED to pin 11, the cathode to one of the pins of the 220 ohm resistor, and the other pin of the resistor to GND. With our circuit ready, it's time to upload the program to the Arduino. Here's how the code works. First, we initialize the pins. We've got the constants and floats and long. Next, we set up the sensor, and then finally, we measure the distance. This Arduino program measures the distance to an object using an ultrasonic sensor and controls an LED based on that distance. Here's a step-by-step explanation of how this works. The two lines digital write and delay microseconds sets the trig pin to low for 2 microseconds. This ensures a clean signal when we send the trigger pulse. Then we send the trigger pulse. The 3 lines digital write trig pin high, delay microsecond 10, then digital write trig pin low, sets the trigger pin to high for 10 microseconds, and then sets it back to low. This creates a 10 microsecond pulse, which is required to initialize the ultrasonic sensor. After that, we measure the distance. We use the pulse in function to measure the time that it takes for the echo pin to go high, which is the start of the echo, until it goes low, which is the end of the echo. The time is measured in microseconds and is stored in the duration variable. Then, in this formula here, we calculate the distance. This calculates the distance based on the duration of the echo. The speed of sound is approximately 343 meters per second, which is 0.034 centimeters per microsecond. The duration is then divided by 2 because the sound wave travels to the object and back. These 2 lines here print the calculated distance to the serial monitor, which helps in monitoring the distance readings. These lines here check if the measured distance is less than or equal to 10 centimeters, and if true, the LED connected to LED pin is turned on high. If it's false, then the LED is turned off. Finally, we've got delay 1000, where the program waits for 1 second before repeating the loop. This helps in providing a readable output that reduces the frequency of measurements. Let's see this experiment in action. As I move an object closer and farther from the sensor, watch how the distance changes on the serial monitor. Here I'm using an oscilloscope that I have connected to the sensor. The oscilloscope has got 2 channels. One channel, which is the yellow channel here, I've connected to the trigger, and then the other channel, the blue channel, I've connected to the echo. And you can see here the width of the echo line as compared to the distance between the object and the sensor. As I am decreasing that distance, then the width of the blue line is decreased, and the opposite happens when I increase the distance between the sensor and the object in front of it. It is the width of this blue line here, the echo line, that helps us calculate the distance between the sensor and the object in front of it. Before we wrap this up, let's understand how the ultrasonic sensor works. The HC-SR04 ultrasonic sensor operates on a simple but clever principle called echolocation, which is similar to how bats navigate in the dark. The sensor has 2 main components, a transmitter and a receiver. When triggered, the transmitter sends out a short burst of ultrasonic sound waves at a frequency of 40 kHz. These waves travel through the air until they hit an object and bounce back towards the sensor. The receiver, waiting for these echoes, picks them up and records the time taken for the echo to return. Considering the speed of sound is approximately 340 meters per second, which equates to about 0.034 centimeters per microsecond, we can calculate the distance to the object by using the formula distance equals time times speed of sound divided by 2. The division by 2 accounts for the distance being the return journey that waves travel to the object and back. By measuring the time between sending the signal and receiving the echo, the Arduino can calculate the distance to an object with surprising accuracy. This makes ultrasonic sensors invaluable in robotics, car parking sensors, and automated manufacturing where precise distance measurement is crucial. And there you have it. You just build a simple distance measuring tool with the Arduino and the HCSR04 ultrasonic sensor. If you enjoyed this video, please hit the like button, subscribe, and ring the bell for more awesome Arduino projects. Drop your questions and suggestions in the comments below, and I'll see you in the next tutorial.